Hello, welcome to this lesson of our study of partial differentiation. Okay, so in this lesson we just go through what we mean by linearization and linear approximations. Okay, all right. So if you have not subscribed to the channel, kindly subscribe to support the channel as well. Okay, let's start. So find the linearization L of x y z. Oh, sorry, L of x y. Okay, I mean this one of the function f of xy equals x squared minus xy plus half y squared plus 3 at the point this. Okay, so in other words, the linearization is simply Taylor series expansion of a function of several variables where we truncate at the first derivatives. Okay, so to do this, if you have a function like that, the linearization is given by f of x naught y naught, where these will be the point given, okay, plus fx simplified at the point p naught, okay, or the p, then x minus x naught, okay, plus fy simplified at p, then y minus y naught. Very simple like that. Okay, so with this particular question, f of xy is giving us this. F of xy is giving us s squared, okay, s squared minus xy, okay, plus half y squared plus 3, and the point p naught was giving us, so let's say p naught, okay, p naught was giving us 3 2. Okay, so first of all, from the equation, what we need first is our f of x naught y naught. Okay, this, so you just simplify it, the function at the point p naught. Okay, so f of x naught y naught, okay, is simply just putting these values inside. Okay, and this will give us when you simplify, you get 8. Okay, so just try to go through it. Then we need our fx, okay, simplified at that point, and fy simplified at that point. So fx is actually equal to 2x minus y. Okay, and when you simplify the point, fx at the point p will be equal to 4. Okay, so it's 2 times 3, which is 6, minus 2, which is 4. And fy is simply also equal to minus x plus y. Okay, and then fy simplified at p is equal to -1. So we have everything that we need. Then our linearization, which is the L xy, is now equal to this f of x naught, y naught plus, okay, so 8 plus fx simplified at p, which is 4, into x minus x naught, which is 3. Okay, then minus 1 into y minus y naught, which is 2. Okay, so if you simplify this correctly, you get something like this: 4x minus y, okay, then minus 2, right? So it's like 8, then 4 times this will give minus 12. So 8 plus minus 12, which is minus 4, then 1 times this, which will be plus 2. So just like that, you just simplify as you know. Okay, so that is the solution to the first question. Let's go ahead and solve the remaining ones. So find the linearization L of xyz of f of f of xyz, given us that at the point this. Okay, so the difference here is that this is in 3 variables. Okay, so when it is in 3 variables, Lx yz will be equal to f of x naught y naught and z naught. That's the very difference. Then fx simplified at p, x minus x naught, plus fy simplified at p, y minus y naught, and plus fz simplified at p, z minus z naught. Note that this is different from the tangent plane. Okay, for the tangent plane, the last question we solved was about, implicit differentiation, but here the function is given. There's no implicit, okay? There's no equation here. It's just a function given. All right, so to continue with this, all that we need is at the same time f of x, y, s naught, y naught, z naught. But you know that f of x, y, and z is giving us. So you go ahead and write that one as well. And that is s squared minus xy plus 3 sine of z. Okay. Now it means that at this is a point p naught. P naught is 2, 1, 0. So at this point, f of x naught, y naught, okay, z naught, just putting them inside the function, we'll get 2. Okay, try to simplify it and that will work, okay? And then fx will be equal to 2x minus y. And that 2 fx simplified at p will be equal to 3, okay? Because I have 2 times 2, which is 4 minus 1, that is 3 indeed. And fy will be equal to minus x, and with that fy simplified at p, just putting the x value there, and that is minus 2. Then fz is also equal to 3 cos z, and with that, if you simplify this at a point p, we put z value in place of the cos aspect, you have fz simplified at p to be equal to 3. So we have everything that we need. And so our final answer to this question will be just L of x, y, z, okay, will be equal to f of s naught, y naught, z naught is 2, then plus fx simplified at p, 3 times x minus s naught, which is 2, minus 2 into y minus y naught, which is 1, then plus 3 into z minus z naught, which is 0. Okay, so z, like that. So in effect, if you go ahead and multiply it through everything and you simplify, this is what you get. You get 3x. I believe you can do the simplification. Just expand every bracket, group the variables, and then add the numbers. Okay, minus 2y plus 3z minus 2. Okay, so that's the linearization of the function giving us this. Okay, I hope you can see it. Now let's move ahead and solve one question under linear approximation. Okay, use linear approximation to find the approximated value of the expression this. Indeed, we can point this on a calculator and approximate it straight away and go. Okay, and we'll be okay. But we can use our ideas in linearization that we just did to approximate this value. Okay, so what you do here is that, first of all, the questions can come in different forms. Okay, but this is the one particular question I'm just solving with you. Even beside with the previous one we solved, even after simplifying and getting something like this, your tutor or your lecturer can ask you to find L of 1, 2, 3, meaning wherever you see x, y, and z, you put 1, 2, 3 there, just like that, and find the values. Okay, so we are going to write, that's the same idea we are going to use here. We're going to write these this as a function, okay, and write the linearized form of it. Then after that, we use it to approximate this. Okay, so we just say that solving this is what we say. Since we have this expression 1.1 log of 4 times 0.05 plus 1.1 squared, you could see that 1.1 is here, 1.1 is here, and there's a 0.05 here. Okay, so you can see that the numbers that are repeating, this repeated the 1.1, okay, and also 4 is multiplying something as well. So you can choose to call some of the numbers as r, x, and y. Okay, any way you do it, it will work. Okay, so you can let our x be equal to 1.1 and our y be equal to 0.05. In that case, we'll have a function as this: x log of s log of 4y plus x squared. Then we'll call this our f of xy. Okay, and the function the value we want to approximate is what? We want to go ahead and approximate f of x is what? 1.1. Okay, then 0.05. You want to approximate this, okay? Or let's say it shouldn't be f, it should be L of that. Okay, after the linearization, we want to approximate L of 1.1 that. Okay, so you have to find the linearization of this f and then use it to approximate this value. Okay, but we said that the linearization is giving us L of xy is giving us f of x naught y naught plus fx simplified at p, then x minus x naught, okay, plus fy simplified at p y minus y naught. Okay, now with this, the question is, what is our f naught, s naught, and y naught? So you just look through the function given. The function is a logarithmic function. Okay, what are the values? We should choose a value that is really close to these values, really close to this and this, the 1.1 and 0.05. Okay, but in such a way that when you choose and put them here and you simplify f of x naught y naught, you will get a single value or get a very simple answer. Okay, so let's try to make sure that y is 0 and see. When y is 0, what will happen? We'll have something like x log of 0 plus s squared. Now we don't know x. We want to choose. I've already chosen something for y, so let's say y naught is 0. Then what will be x? So that the answer here will be very simple, either a whole number or very simple 1.2 or 1.1 or 1, or let's say a certain whole number like 0 or 2 or negative 1. Okay, the only option that we can have here is when x equals 1, because when x equals 1, this x here will be just 1, and we'll be focusing on whatever that is inside here, and that 1 square will be 1, so we'll have logarithm of 1, which is equal to 0, and that will be perfect for us because we want to find f of x naught, which is very simple. The answer will be very simple. So we'll let our p be equal to x is 1 and y is what? 0. So here you can see that, compare these values, this 1.1 and 1, the error within them or between them is 0.1, and the error between this and this is 0.005. They are very, very small, so this will do. Okay, all right, then what we need is what? Just go ahead and to the next page. F of xy. Okay, let me use the white pen. F of xy is now equal to, is x log of 4y plus s squared. Okay, so we need f of, and the p is 1, 0. F of x naught y naught is just putting the p values here, and that will give us 0. Okay, because 1 times log of 1 will be 0. Okay, log of 1 to any base is 0. And remember, in college, when you just write log without any base, you mean the natural logarithm. Okay, so fx will be equal to differentiating the whole of this with respect to x, and this is a product rule because there is a function in terms of x here, the whole of this, there is an x also there. So first of all, you differentiate the first x, and that will give us 1. So we have log of 4y plus s squared, then plus the differential of the log. Okay, and that will give us just x times the differential of the log, and that will give me 2x over 4y plus s squared. I hope you know how to differentiate logarithm. So in other words, this s will come multiply the 2x and we'll get something like 2s squared. Okay, I hope you understand this. Now fx simplified at p will be equal to, just put p there, and we'll have 0 plus 2 over 1, okay, and that is equal to 2. Now we have to find fy. There's no y here, so there's no product rule. So I have for x, okay, differentiate the brackets, multiply it to the x, then all over whatever that is in the bracket, because that is how you differentiate len. And this, when you have fy simplified at p, will also be equal to 4. Okay, so we have everything set. We have f of x, y, s naught, y naught. We have x, f of x, or fx simplified at p, fy simplified at p as well. So all that we need to do is just write our linearization, which is equal to f of x naught, y naught. Okay, let me write them straight. And that one was equal to 0 plus fx simplified at p, and that was equal to 2 into x minus x naught, which is x naught is 1, okay, and plus 4 into y minus y naught, which is 0. So we have L of xy equal to 2x minus 2 plus 4y. So we'll have this to be 2x plus 4y minus 2. Okay, so now this is what you have. So the question is, you are supposed to use this to approximate the logarithmic expression that was given, and that the actual values we wanted to approximate was 1.1. That was for x. That's what I chose. Okay, so you can choose y to be that. It doesn't change anything. Okay, so I want to approximate this. So L of 1.1 comma 0.05 would then be equal to, putting everything here, 0.4. Now you can go ahead and check the expression on your calculator and see. Okay, so this is the answer. This is the approximated value of that. Let's check. You can check if you are indeed approximate, or you are indeed close to the actual value, because the actual expression was 1.1. okay, so 1.1 logarithm, and that I said is len. Okay, so len of 4 into 0.05, then plus 1.1 squared. Okay, and the answer is 0.3779. okay, so in approximated to, or in approximation of just one variable, this is the answer we had. Okay, and the actual answer is 0.3779, let's say, to 4 decimal place. So if I approximate this to 1 dp, you get something like 0.4. okay, I hope this is okay. So thank you, and don't forget to subscribe to my channel. In our next discussion, we'll talk about different topics as well, so stay tuned and support the channel as well. All right, see you next time.